Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. This week, we're going to be taking a step back and we're going to be looking at how do you code in Python. Now, I realize a lot of my videos are me already knowing how to code in Python, and you kind of need to come with some of that understanding in order to do some of these machine learning tasks. But I want to take a step back for those people who maybe want to learn Python or have heard of Python and not really sure what it is and want to see how it can be used for them. So, this series, we're going to be looking at what are the basic things that you can do with Python, and as the series progresses, we're going to get harder and harder tasks and look at some different packages that are available in order to make it a little more efficient and a little more easy to use. So without further ado, let's jump over to the Jupyter Notebook and we'll get started with learning our first operations in Python. Okay, as you can see, we have our Jupyter Notebook open. Now I have this template I'm going to use right here. And there's some other files that we're going to be looking at as well. If you would like to go ahead and download those, go ahead and move over to the GitHub page. And within Python Party, you'll see there's module 1, which is what we're on right now. And you can go ahead and download the templates and some of these sample text documents. And I even threw the solutions in here as well if you want to reference those. You don't need to. Most of it we'll be able to just do straight from your Jupyter Notebook. So if you haven't used Jupyter Notebook before, I do have a tutorial on it, but we'll go over a lot of it here as we move along anyways. But essentially what Jupyter Notebook does is allows you to move between text like this and actual coding lines. And then within the blocks of code, you can execute those individually. So it's almost like multiple scripts that you can run within the same environment. So to get started, let's do probably the most common thing that everyone learns how to do when learning a new coding language, and that is printing hello world. So Python is super easy, and it's almost like a written language where you're just telling it exactly what you want it to do. So for instance, the print function is literally just print, and it's going to print whatever is in the parentheses. Now, if you're going to print a word like we are about to, you will need quotation marks, or you can use the single quotation mark. Either one will work, but we can just type in hello world and end your parenthesis, and that is everything you need to do to print something. So if you are in Jupyter Notebook, you can hit Control Enter, or you can hit the play up top, and as you can see, it will output hello world. Now, if you want to output multiple things, we can have multiple print statements. So if I want in the first one to print hello, and in the last one, I want to print world, we can do two separate prints. And as you can see, it will print both of those on separate lines. Other things that you can do with the print function, go ahead and put another print there. You can print multiple words, multiple variables, whatever you have. So you can do something like hello. You can end the quotation marks. You can do a comma followed by world and then followed by an exclamation mark. Now, each of these is separated by a comma. They will print a space in between each one of these. So if we go ahead and run this, you can see a space was put in between each one of those individual ones. And that would be super helpful when we get into the more complex tasks that have a lot of variables that we need to print at one time. Other things you can do is you can actually save these strings as variables. So I'm just going to call it A, and we're going to call this one hello. B is going to be equal to world, and C will be our exclamation mark. And we can, just like we did in this one up here where we had the strings right in there, instead, we can say print A, comma B, comma C, and it's going to print each one of those individually and put a space in between where those commas are. The last thing we can do is, since these are all characters or strings, we can do math operations with them, with these strings, and we can say, I want to take A, which is hello, and I want to add a space, so just put a space in between your quotation marks. And then I want to add B, and I want to add C without a space, and that will get rid of that extra space that we had with that exclamation mark down here. If you go ahead and run that, it will add all of those together and give you the original string that we have at the very top. So that's basics for printing and strings. Now we can move on to some other things like math operations. So I'm going to replace A with 1 and B with 2. So now we have integers that we're using. And so I can combine strings and integers and math operations all together in a print statement. So I can say print, we'll do add for this one. I'm going to do a comma after I say add, and I'm going to say A plus B. If I go ahead and print that, you can see we get 3, which is 1 plus 2. If you want to save another variable as the sum, you can say C is equal to A plus B. And then you can do another print statement that says add, and just print C instead of the actual operation within there. And again, we can see that that is 3. Now, besides addition, there's a whole bunch of other things we can do. So I'm going to copy this one that we have up top here, and I'm just going to paste this a few times. I'm going to replace this add with subtract, and obviously in here you can do A minus B. Multiply will be the next one, and replace that with the star, so A times B. Divide is going to be a slash, and the last one I'll do is exponent, and that is going to be a double star, so A to the power of B. If we go ahead and print all of those, you can see what all of those results are and just verify that they are correct. But that's the basic of what you can do with numbers, and there's a lot of other things you can do when you start importing other packages, but we'll get into that as we progress throughout this series. Next, we'll talk about what a list is. So I'm going to define a variable called x. I'm going to use a square bracket. And inside of x, I'm going to do a whole bunch of integers. So I'm going to say 1, comma 2, comma 3, comma 4, comma 5, and end that square bracket. Now if I print x, you can see it will print exactly what I have here. But the cool thing about it is I can reference each individual point within this list instead of having to define a variable for each one of these. So what I can do is I can say print x, and then if I do another square bracket, I can say at the first position. Let's go x at 0. Print that. Now, when you do indices, it starts at 0. So while this is the first position in the list, it is really the 0th indice. So it would be 0, 1, 2, 3, and 4. So printing the 0th position is 1. If I go and do an x at position 1, it will give me 2, and so on. Now I can also take chunks of the list. So I can say I want the first indice through the third by using a colon there. And that's going to print the first indice, the second indice, and now it doesn't print the third. It only goes up until the third. So if you wanted to print the third indice as well, so this number 4 right here, you would have to make this a 4. And you can see now you're printing 3 of those positions. Other things you can do with it, like we had above where we could do some operations, some math operations. You can say, I want to take the x at position 3. So 0, 1, 2, 3. It would be number 4 here. And I say 4 minus x at position 0. And that would be our 1. And you can see 4 minus 1 is 3. So you can just reference those individually like that. You can also determine how many numbers are in the list. So print the length, len, of, and then you pass it your list. So the length of x. You can see there are 5 numbers within this list. If you need to add numbers to your list, you can say x.append. And then let's say I want to add 6. So what this is going to do is going to add a 6 to the end of the list. And then we can just say print x. And as you can see, that 6 is now at the end of the list. So that is ways of manipulating and using a list. This would be helpful in the exercise we have coming up. But the last thing I'll show you before the exercise is different object types. So an object type is things like what we've been looking at: strings, which is a list of characters. A single character is another object. You have integers, which are whole numbers. You have floating points, which are decimal numbers. And so we can look at each one of those. I'm going to define a new variable called s. And s is just going to be equal to a character. And in this case, the character is going to be a 1. Now, in Python, this is going to be considered a character. So if you try to add a 2 to this, it won't recognize it because this is not a number. And so you can go ahead and check out what kind of object that is to make sure by saying, let me just print what the s is, and then we can say type, and you can pass in whatever variable you want to use. So I want to know what the type is of s. And as you can see, like I said before, this is a string. So it's not a number within this script. There are ways of changing it to a number. So if I now say s is equal to an integer, I can say int and then pass it s. Now, when I take this same line right here, the print line, and print it, it has converted this one to an actual whole number. So now we can do math operations by adding other integers or floating points to it. Speaking of floating points, we can go ahead and do that one next. So if I say float s, and then I use that same print statement, so printing the s and the type of s, you can see this 1 has now turned to 1.0. A floating point is a decimal point, so it will add those automatically in, and the class is now a float. The last one I'll show is going back to a string. So if I say s is equal to str of s, that's standing for a string, and I do that print statement one more time, you can see we have successfully gone from a string to an integer to a floating point back into a string. Now the string in this case is 1.0 because we converted this number, which was a float already, into a string value. So something to be aware of. If you wanted to convert it back into an integer, you would have to say the string of the integer of s. But for now, that is what our individual object types are. Now, moving down to our very first exercise. So I want you to go ahead and pause this after I get done explaining it and try to do these steps right here and come up with your answer. And then go ahead and unpause it and see if you were able to get exactly what I got here. So what we're going to be doing is I want you to create 4 variables that are holding each one of these numbers, and some are negative numbers, positive numbers, integers, floats, but I just want you to make these 4 right here, and then I want you to plug them into this equation. A times b plus c times d to the power of a, all of that over b minus c over d. And I want you to come up with whatever your solution is. You can call it y, you can call it whatever you want, but I want you to, after you have it, go ahead and print the sentence, this is my answer, colon, and then print whatever your answer was, whatever your variable was. So in this case, I was using y, so I would just print whatever that sum was. So go ahead, pause the video here, try to do that, come back when you think you have an answer, and we can see if you have done what I have for this answer. Okay, so assuming that you pause the video, let's go ahead and move on. So A is going to be equal to 5. B is going to be equal to -3. C is going to be equal to 4.3. And D is going to be equal to 10.11. So we have all of our variables, and the first step is done. Now we're going to make this equation right here. So we're going to say y, I'm going to call my variable y, is going to be equal to, and in here you can use parentheses. So parenthesis, I'm going to say a times b plus another parenthesis, c times d to the power of, remember that's the double star, to the power of a, and all of that is going to be over b minus c over d, and end that parenthesis. Now, if you're in Jupyter Notebook, cool thing is, as you can see, I'm at the end of this parenthesis, and it's telling me which one I am closing by making it green. So I can tell you if you've closed all of your parentheses. Last thing I was having you do was to print out that statement. So this is my answer with a colon. Now I'm just going to do a comma to add that space in, and I'm just going to print the y. Now this hopefully was the answer that you got. maybe you don't care necessarily about all of these decimals at the end, so I can also show you how to round that. If you take this print statement and paste it down here, one thing you can do is you can round this y value. You can say round y, and then you need to tell it how many decimal places. So I'm going to say 2 decimal places. So it's round whatever you're trying to round, comma, however many decimal places. You print that, you can see it's shortened that to just 0.86 at the very end. Okay, so we got past the first exercise. Hopefully you were able to complete that. If not, you can go ahead and just, if you want, change what this equation is. See if you can come up with the actual answer. Maybe do the math on the side to figure out if you are coming up with the right answer and maybe where you're going wrong. But we're going to move on, and we're going to be looking at our loops that we can use. So probably the most common one is a for loop. And what I'm going to do is I'm going to define a new list. So I'm going to call this nums. And like before, I'm just going to say it's equal to 1, comma, 2, 3, 4, 5, 6. We'll go to 7. And now what I'm going to do is I want to just move through this list one by one and print out what the values are. So I can say for x in nums. So for each value in numbers, you have to end it on a colon if you're using a for loop. And now if you hit enter and you're in Jupyter Notebook, it automatically tabs for you, so you know you're still within this for loop. And we're just going to do a print x. So what this is going to do is it's going to step one by one through numbers and save whatever the number is in x, and then we can just print the x right to the screen. Running that, you can see 1, 2, 3, 4, 5, 6, 7. Okay, now something else that may be useful and probably will be useful is instead of stepping through what the actual numbers are, you could step through whatever the index is. Remember, while this is the first position within the list, it is the 0th indice. And so what you can do is you can say for x in. Now you can say range of the length of numbers. So what range does is it's going to take the length of numbers, which in this case is 7 numbers, and it's going to order them from 0 to 0, 1, 2, 3, 4, 5, and 6 until it hits 7 numbers. And so when you go ahead and print this, let's just go ahead and print the x again. I did not make this plural, so make sure it's the length of nums, not num. And we're going to separate these lists because they're colliding a little bit. One thing you can do is you can print a \n, and this is going to be a return. So it's going to print a blank space. And now you can see we have a blank space in between our two outputs. But like I was talking about before, instead of printing the actual numbers, it's printing the indice of each of the numbers. And why that's important is, well, if you, within this print statement here, instead of printing just x, you can now print nums. And then remember our list exercise above, we can say at x. So now it's going to print the indice, and it's going to print the number at that indice. You print that, you can see the 0th position is 1, and so on down to the 6th position, which is 7. Hopefully that makes sense. We'll do some exercise with those so you can kind of see when you want to use one over the other. Next loop is going to be a while loop. So again, I'm going to define nums as exactly what we had before. So 1, 2, 3, 4, 5, 6, and 7. Now in a while loop, unlike the for loop where it was automatically figuring out how long to run for, a while loop will run until a condition is met or it's told not to run anymore. So we need to set a counter. I'm going to call it I, and I is going to be equal to 0. Now, just like the for loop, it's going to be while, and now it needs a condition. So it needs to know when to stop. I'm going to say while I is less than the length of numbers. So while we haven't reached the end of the list, you're going to do something. Now, once it's, in this case, equal to the length of numbers, it's going to end. Now, it's not going to end on 7. Remember, this is looking at the index. So the 7th number is really the 6th index. And so it will end right before, or right at the very last number, and it won't go any farther. In here, we're going to print, just like that last for loop we did, the nums, and in this case, it's going to be at I, since we changed the variable to I. And this is very important. You cannot just run it like this because we haven't updated I, so it's just going to run forever, printing the very first element. So what we need to do is we need to change the value of I. So we need to reassign I to be equal to I plus 1. So we're just incrementing by 1. Another way you can write this statement right here is plus equals 1. This will automatically add 1 to I. You can do the same thing with minus equals, times equals, whatever the case may be. It's just going to take whatever's on the right, do the operation, and apply it to the thing on the left. Okay, now that we have our counter and our counter is being updated, now we can go ahead and run it. If you do run into a never-ending loop, you can hit the stop button here and it's going to automatically stop whatever cell you're running. If that doesn't work, and sometimes it doesn't because it's really jamming through some numbers, you can restart the kernel by hitting kernel and interrupt or restart, and it's going to completely stop your code and reset everything. Okay, so that is a while loop. Last thing I'll show is nested loops. So this isn't a different loop type, it's just different ways of using those loops. So if I have nums, and again, we're gonna just make it 1, 2, 3, 4, we're gonna stop at 5. We don't need too many here. So we have our numbers. I'm gonna make another list called alphas for letters. And we're just going to say A, B, C, D, we'll go one more, E. Now it's super important. Since these are strings or characters, you do need the quotation marks in each one of these individually. You can't just make one long one or else it's going to be one massive string. So make sure you individually put quotation marks around each one of these. And again, it can be a single quotation mark or it can be the double. So now we have numbers and we have our characters. So what I can do is say for num in nums. So for each one of the numbers, we're going to do something. And then I'm going to make another for statement. And I'm going to say for, let's say, letter in alphas. We're going to cycle through that, and then we're going to say, I want to print whatever the number is, and I want to print whatever the letter is. Now, before I run this, let me explain what it's going to do. So the outside loop is going to run through each one of these. So the first one is going to be a 1, and then within here, since we're doing another for loop, it's going to run through all of the letters. Now, it will only increment the numbers once it's done with this for loop. So you're going to see that it's going to stay on the very first position, and it's going to run through all the letters. Then it's going to increment the number, and it's going to do it all over again. So let's go ahead and run this. And like you can see here, the numbers, since it was on the outside, it was the outsidemost for loop, it's going to stay a 1 until it makes it through all of the letters. So A, B, C, D, E. It's going to increment the numbers, and it's going to run through all of the letters again. And it does that all the way until the end of the numbers list. So super useful for something like our, maybe not the next exercise, but in a couple exercises, we'll see some nested loops. So let's go ahead and do exercise 2. And we're going to be using those loops that we just saw up top. We're going to actually use the for and the while loop in order to do some math operations and come up with some values that we're looking for. So first thing you need to do is create a list with all of these numbers right here. Within a for loop, you're going to add each number, right? So you're going to add the first position of A to the first position of B. So this would be 1 plus 5. Then you're going to move on to do the second position times the second position. So 2 times 4, and 3 times 3, 4 times 2, 5 times 1. You're going to work through all of those and get the product for each one of those. And then what I want you to do is I want you to store it in a new list called C. So if you remember up top when we're using list, you can do an append. Now what's important here is you can define a blank list. So this would be useful is if you say C is equal to a blank list, and then as you're looping and coming up with a product, you can append all of those answers to this list. Once you have your list, go ahead and print this is my list and just print that variable out. In this case, I made it C. And then once you print it out, I want you to use a while loop to run through the values in C and sum the answer. Now, again, I'm going to help you out a little bit here. Like we did in the while loop where you can do an I is equal to, or I plus equals 1, where it just adds 1 to the value of I. You can do the same thing with a sum. So you can have a running sum, and you're just constantly adding the new value to it. So hopefully that helps you out when you try to do this. But go ahead, pause here, and try to complete this exercise. Come back when you think you have an answer, and I will run through what my answer will be for this. Okay, assuming that you pause the video and you're ready to go, let's go ahead and do this. So first step is making those lists. So I'm going to say A is equal to 1, 2, 3, 4, 5. B is equal to 5, 4, 3, 2, 1. Okay, we have our two lists, and now we're going to use this empty C list right here. So I'm going to move that up, and we're going to use a for loop to start coming up with those products. So for, and in this case, I don't want to say for each value in A, because I also want to reference the same position in B. So I'm going to say for X in range, the length of A. So for each position in A, we're going to do something with it. And I'm going to make a temporary variable called temp. And I'm going to say I want the A at X. So I want whatever the indice is, A at X times B at X. And that will give me the product of whatever position I'm at right now. After that, I want to say c.append. Go ahead and append the temporary value you have right here by doing the multiply. And after that for loop's done, you're now going to have a list with all of your products. So in step 3, let's say print this is my list with a colon. And I'm going to do a comma C. If you print that out, you can see 1 times 5 is 5, 2 times 4 is 8, and so on. So we do have the products right here. Now we're going to go to step 4. We're going to use a while loop to create a sum of all of those values. Now, like I said before, where we had our while loop and we were able to add to something, we're going to make a sum, and we're just going to initialize it as 0. And we also, in that while loop, had a counter, so we need that as well. I'm going to make this I. So we have our counter and we have our running sum. And now we can do our while loop. So while I is less than the length of C, so we're going to run until the end of the list. We're going to say sum plus equals the value of C at our index. So we're going to use our counter as our index because that's what it will be since we're starting at 0. So we're going to take the value of C at each of the indices, and we're going to add it to the sum. Now remember, this is a while loop, so we do need to update that counter by adding 1 to it. Now we can do the step 5, which is printing the list again. So this is my sum. And then I'm going to print sum. Go ahead and run that, and you should get, this is your list, and then you should get the sum of 35. Again, if you didn't, go back and try to see what you did wrong. Maybe you change some variables and see if you can do it again with a different list or with different numbers and try to come up with an answer. But for everyone else, let's go ahead and move on to our if statements. If statements are super important when you're working in Python because you're going to use them all the time. Along with your for loops, if statements are a huge part. So let's get into what they are. I'm going to make 2 variables. I'm going to say A is going to be equal to, let's make it 5, and then B is equal to 5 as well. An if statement is going to check the condition like we had in the while loop. If you go up to here where you have some thing that you're trying to check. You want to check if I is less than the length. The if statement is going to do exactly that as well. So coming down here to the cell, I can say if A is equal to B. Now it's important in the conditional test that it's a double equals, not a single equals, because you're not trying to assign A is equal to B. You're trying to do figure out if A is equal to B. We're just going to print yes. Like the for loop, if you're in Jupyter Notebook, it's going to automatically indent for you, so you know. Let me just make sure it's yep. So you know that you are under this if statement, and then you're going to execute. If it's true, you're going to execute any code that's under it. So if I go ahead and run this, you can see yes is printed. Now if I make B 7, now A is no longer equal to B. It's not going to print anything because it's not executing this code right here. So you do need to, you possibly need to add a condition for when they're not equal. So if you want just a catch-all, you can say else. Make sure that colon is there, and you can print no. So what this is going to do is it's going to try to see if A is equal to B. If it is not equal, it's going to move automatically into this else statement and print a no. So if we run that, it goes right to a no. If I change B back to being equal to 5, you can see it only executes this top one because that's where it ended up in. Now, if you have multiple conditions that you are trying to determine, you can go ahead and make a elif statement. So this is basically if the first condition is not true, you can do another if statement after it. So this is else if, and then else if is looking for, unlike else, it's looking for the next condition. So I can say if A is less than B, we can print less than. I'm going to come up here to this equals. Instead of yes, I'm going to say it's equal to. And then I could do another else if that says if A is greater than B. We're going to print greater than. Now, it can only be equal, less than, or greater than. So if it's not, then it should never get to this else. So I'm just going to say no idea if it gets down here. But let's go ahead and run this a few times. So I have A is equal to B right now, and so it's going to print equal. If B is greater than A, in this case, it's looking at the A first. So it's going to say is A less than B, and it's going to print less than. And if I reverse these and say A is 7, B is 5, then it's greater than. So ways you can use if statements. Now, if you were to change this, and instead of using else if you only had an if statement here, what it's going to do is it's going to check this first if statement, and if it's true, it's going to run the code. Then it's going to make it to this next if. So it's going to check the next if statement and run the code again. So you need to be careful with that, where if you aren't using else if, it's going to run each one of these individually instead of stopping after the first condition is true. And maybe you want that, maybe you don't, but again, something to be aware of. Okay, let's move into exercise 3. Now this one's a little tricky, but it's a cool way to learn how to use some of these looping and conditional statements. But what we're going to try to do is print this design I have on the screen right here, this little hourglass design, and I want you to print it within a for loop. So instead of printing each one of these lines individually, I want you to come up with some logic that will figure out what line it's on and what it's supposed to be printing. Something that will probably be very useful for you in this, it's not necessary, but it's going to make your life a lot easier, is let's say I have, let's just look at the very first line here. There is 16 hyphens. So a hyphen will look like this as a character. And let me just do a print. So if I print a single hyphen, it's going to look like that. If I want to print 16 hyphens, I can take that hyphen and I can say times 16. And it will print 16 of those hyphens. So you don't have to worry about making a string and adding each individual hyphen to it until it hits 16. this will automatically print it for you. So that will be helpful when you're trying to like fill in these colons in the center or those hyphens or maybe the spaces on the outside. So go ahead, pause the video here, see how far you can get. If you don't get to the solution, that's okay. I will run through how you can put this together. But at least go ahead and attempt to do it and then come back. Okay, I'm going to assume you paused, you tried, and you came back with a solution. So let's go ahead and look at how we can do this. As I said, there are 16 hyphens in each one of these. So each line is 16 long. Now, as we look in the center of the hourglass, it's a mixture of straight lines, colons, spaces. And so we have to come up with some math to figure out how many of each we need. We're going to use a for loop. So for x in range. Now, before we were using the length, but what you can do instead is you can actually put in a number here. So there are 17 lines here. So for x in range 17. Now 17 lines is the number of lines from top to bottom. So we're going to work our way one by one all the way to the bottom. Now the very first line and the very last line are the same. And so we can do some logic here to figure out when we should be printing those. So I can say if x, so x is whatever line we're at, if x is equal to whatever the indice of these are. So first line is going to be the 0th indice, 17th line is going to be the 16th indice. So if x is equal to 0, you can print what we just had before. So the hyphen times 16. And we can go ahead and make another statement that's a elif x is equal to 16. We're going to print this same thing here. Now, if you want to make this cleaner, there's a way to do an if statement with multiple conditions. So if I delete this and go back up here to this original if statement, I can say if x is equal to 0 or x is equal to 16. So now it's going to move down here if either one of these conditions are true. If I change the or to and, it's going to move into here only if both sides of these conditions are true. So just something you can use to clean up your code and make it a little easier to do multiple things. But we are going to print 16 hyphens if that is the case. And for now, I'm just going to run that. I do need an else. So else, I'm just going to print a blank line for now just to make sure that we are putting these in the right area. Okay, so first line, and this will be the 17th line. I know it looks really big, but that's because this return is pretty large. So actually, I think if I replace it with a space, there we go. So now it is the correct size. And we can start working on, okay, it's not the first or the last line, so now we need to start making this design right here. Things we need to make for each one of these lines. Each of these lines has two straight lines, one on each side of it. It also has this fill with the colons, and it has some number of white spaces before each of those straight lines. So we need to come up with some values for each one of those. Now we also need to be concerned with how far down the list we are because it starts reversing at some point. And it's going to reverse at x is equal to 9, I believe. And so let's start by looking at x is less than 9 or less than equal to 8. So if x is less than equal to, I don't think we covered this. This is how you include whatever you are trying to look at. So if x is less than equal to 8, this is the top half of our hourglass right here. We need to figure out how many spaces are in each one of these lines. So we look at the second line, which is the first indice. So x equals 1 is right here. We have 0 spaces. X equals 2, we have 1 space. X equals 3, we have 2 spaces. So what this is spaces is equal to x minus 1. And that will give us the number of spaces we have. Now for the fill, we need to come up with some equation for that. So we're going to say fill. I'm going to put this within the if statement still. So we're going to say the fill is equal to, remember there are 16 spaces here. So we're going to take 16. We are going to subtract 2 for the number of straight lines. And then we're going to subtract the number of spaces times 2. The reason it's times 2 is because you not only have one space on this side, you also have one space on that side. So after you get rid of the straight lines, the number of spaces, everything left will be the number of colons that you need. So we can do a print. First thing we need to print is our number of spaces. So print a space times spaces. Oops. This will print all the spaces that we need. After this one, we're going to print a straight line. Now, if you do a comma here, remember the comma will automatically add a space and it's going to mess everything up. So if you add to the strings as you're going, this will be a way to get around it. Now that we have our straight line, we are going to need our fill. So the fill is a colon times the fill. Remember, that's the number of spaces that we need to fill it with, and then add a straight line at the end. You can also add the spaces at the end if you want, but you're not really going to be able to see those, so it doesn't really matter if you do that. Let's print this, and as you can see, we have printed the top half. Now, we weren't printing anything, so this bottom line moved back up. We could have said else print that space again, just so we have the spacing, but we have our top half now. Now we need to look at what do we do for the bottom half, because now we need to start reversing it. So we're going to say else, because there shouldn't be any other circumstance that it gets in here. We need to recalculate what the spaces are. So if we go ahead and look at the number of spaces, I can do it right here. Okay, so at this point we have 1, 2, 3, 4, 5, 6. We have 7 spaces. In the next line, we are going to have 6 spaces because it's going to move out and it's going to be the same as this line right here. So we're going to need 6 spaces, and it's going to be on the 9th indice. So important to remember that. The next one is going to be 5 spaces on the 10th indice, 4 spaces on the 11th indice, and work all the way down. So we can come up with an equation to figure out how many spaces that we need. I am just going to give you the equation right now. It's going to be x minus 1 minus 2 times x minus 8. Showing you that this works. 9th indice, I said, needs 6 spaces. So if I put a 9 in here, 9 minus 8 is 1. So we're going to be subtracting 2 from 9 minus 1 is 8. So 8 minus 2 is going to give us 6 spaces. And we're going to be able to use that in order to make it. Now, I am going to take this fill and the print statement, and I'm going to remove it, and I'm going to put it under the if statement, because it's going to be the same for printing the bottom as well. So it's going to give us our number of spaces that we're going to use, and both are going to be able to calculate the fill and then print out what we have. So if we run this, hopefully we have no errors. We don't, and we now have our hourglass figure. It's a little bit of a challenging exercise, but I hope you got something from it, because there's a lot going on with it. You have to use for loops, if statements, and it's just a really good way of seeing if you can print a pattern using a for statement. If you want other things like this, there's multiple of these out there. You can even come up with something on your own if you want to. But I hope you were able to get that, and if not, you can always go back and try again or try with a different pattern. Okay, now we're going to look at reading a file. If you did not download those files I had within the GitHub page, open up a notebook. I'm going to open up what it looks like right here. We're going to be looking at this sample text. I just have a whole bunch of random values in here. So you can open up your own notebook if you want to, put a whole bunch of numbers, a single number on each line, save the notebook as sample text. It doesn't need to be these exact numbers. For everyone else, if it was easy, you can just go and download that GitHub folder and you should have this already in there. Another option is to just click in and now you have all those numbers that are actually in that sample.txt. But I'm going to assume everyone has it, so we're going to go back and we're going to learn how to read our file. So we're going to say file is equal to open. We're going to open whatever that file is. So sample.txt. Okay, we're going to open this file and now we're going to read the lines. So I'm going to say lines is equal to file.read lines. And this is going to read every single line within the file. If you do a read line without the S, it's going to take the first or whatever position you're on right now. So just be aware of that. But I'm just going to print the lines to see what we're working with. All right, as you can see, it took all of these lines. Now, if you remember when we printed it before, the /n is just the return character, and it's going to put a new line there. So each one of these lines has the return character, and we can go ahead and start looking at how do we get this to the number instead of the string with the return character and all of that. So let's go ahead and do that. I'm going to save the numbers in nums. So I'm just going to make a blank list that's going to be holding our numbers as we get them. And then I'm going to do a for loop. So for line in lines. If I just go ahead and print line. So we're going to iterate through each one of these lines and we're just going to print whatever the line is. So if I print that, it's going to print each one of these, but it's going to treat this /n as actually giving a return line. So that's why there's spacing in between each one of these. We can replace that by saying the line that we have is equal to line dot replace. I can type. We are going to replace that end character, so /n. We are going to replace that with nothing. So just double quotation mark, but don't put anything in there. If you wanted to replace it with a space, you could also do that, but we won't be able to convert it to a integer if you do it like that. So we're just going to replace that last character with nothing, and it's basically just going to remove it. So now if I run the same code, you can see it's no longer having those spaces in between because we removed that. Next thing we need to do is say line is equal to, and we need to convert it to an integer to make sure that we can do math with it. Now it's going to convert it to an integer. You can run that. You're not really going to see a difference, but if you did the type of each one of these, they would now be integers. And we are going to say nums.append line. I'm going to get rid of this print statement, and we're just saving each one of these numbers in nums. So now if I print nums, let me print a blank space just to separate these two, but you can see now each one of our numbers is an integer and is stored in this list without the /n's and is no longer a string. So that is one way to go from reading a file and making it into the correct type that you need. Okay. Moving to the next one, we're going to make a string. I'm going to call it string. String is going to be hello world, but I'm going to, instead of spaces, I'm going to put slashes. So it's going to look something like this, where each one of the spaces that we had before at the very top are now slashes, and we're going to try to print this string individually and without those slashes. So I can say string2 equals string dot replace. Now, if I wanted to convert those to, spaces, I could say, okay, replace the slash with a space. And now instead of replacing it with nothing, make sure there's a space in between these quotation marks. And if I print, let me print string 2, you can see it just replaced those slashes with spaces. Something else you could do is say, I'm going to make a new variable called string 3, and it's going to be equal to string dot split. And I want to split on the slash. What split is going to do is it's going to read until it finds one of those slashes, and it's going to save this part as a variable. Then it's going to keep reading, and it's going to save this part as a new variable, and it's going to save this one as a new variable. So it's just going to split the string where this value is. So if I print string 3, you can see it is a list of each one of those splits. And if I wanted to, I could say print string 3 at 0, string 3 at 1, and string 3 at 2. And it goes back to printing one single word right there. So hopefully that will help in our next and final exercise. What we're going to be doing is we're going to be reading the other text file that's in there. Again, if you don't have it, you can pause the video and just copy this in right now, or you can go to the GitHub and you can just click on module 1 text, copy this in, throw it into a notebook, or just download all of the documents from GitHub. What we're going to be doing is we're going to be reading in module1.txt, which looks like this. Each line has the trader's name, whatever stock that they are trading. So this is the ticker for the stock. However many, the number of stocks that they have. So right now they have 4 of Apple, and what the current price is. So what you're going to do is you're going to read in each one of those, and you can save those as individual lists if you want, or keep track of them however you want to. But what I want you to do is I want you to figure out who has the largest account. Now, the largest account isn't just what the price of the stock is. You need to say however many, the number of stocks they have times whatever that price is, because that's going to tell you how big their account is. And then what I want you to do is I want you to print this statement right here. So whoever the trader's name is that has the largest account. So figure out who has the largest account, and then I want you to print their name, owns, whatever their account total is in the stock name. So the stock name, again, was like Apple, is this first one right here. And then followed by stock. So again, I want you to find who has the largest account and then print the information for that person. Go ahead, pause the video here, see how far you can get on that, see if you're able to get an answer, and once you do, come back and I will run through how you can actually perform this. Okay, I'm going to assume again that you went ahead and did it, but let's go ahead and run through what the answer is. So file is going to be equal to open, and this one is called module1.txt. I'm going to hide this side here now, and we're just going to run with this. So we're going to open the file. We're going to read the lines. So lines is equal to file.read lines. And then I'm going to print those lines out just to see what they look like. Okay, as you can see, these are all saved as one string. And so you have the trader, stock name, number, and the price. Let us create a for loop for line in lines, and we're going to do something with it. So let me print line so we can see what each individual one looks like. First thing we need to do, we have all that white space. So like we did before, we're going to say line is equal to line.replace. We're going to replace that /n with nothing. It's basically going to remove it. You can rerun it, and now we have all of these in individual ones. What we want to do is we have this common comma and then a space, and then comma and a space, comma and a space. So like we did in the last section, we can split this up. So we can call it splits if we want to. We can say line dot split, and we're going to split on comma space. Instead of printing line, I'm going to print splits. Now you can see each one of these are saved in an individual element within the list. Another thing I could do is, instead of saving it as a list, since I know there's always 4 in here, I can make variables called name, stock, number, and price. So that's going to save each of these individually. So the name is going to go into name, the stock is going to go in the stock, the number here, price here, and it's going to automatically save those into individual variables. So I can say I want to print the name, the stock, the number, and the price, and those are all going to individually print out. Okay, so what am I trying to look for? I'm looking for the person with the highest account. So now I need to figure out what the actual the price of the account is. But before I can do that, I have this little $sign right here, and I'm not going to be able to convert this to a float without removing that $sign. So I do need to say the price is equal to the price. Then I want to replace that $sign with nothing. If I run that again, we no longer have that $sign. Now I can convert the number to an integer. Again, it's a string right now, so you need to make sure it's an integer. And I can print, or I can make the price equal to a float. And it's a float because we do have these decimal places here. So again, go ahead and run that, and you won't really see a change unless you look at what the type of each one of these are. I'm going to make a new variable called account, and account is going to be equal to number times price. And I'm going to do one more print on the end. I'm just going to print what the account total is. So you can see all of these account totals. It looks like 811 is our highest. And so what we're going to do is we're going to do some logic here to figure out, okay, what is our highest, and keep track of that as we begin to read the line. So I'm going to make, way up here before the for loop, I'm going to make a highest account, and I'm going to initialize it to -1. So our highest account right now is -$1. I'm going to remove this print statement. Now what we're looking for is if whatever the account is right now, remember this is line by line, what is the account number? So the first one's going to be 409.28. So if the account is greater than highest account, we're going to do something. So if it's greater than whatever our highest account is right now, we are going to say highest account is going to be equal to whatever the account is, because that is now the new highest. I also want to keep track of highest trader. You're going to be equal to name, and the highest stock is going to be equal to stock. Remember, that's what we have to print out here is the trader name, the account total, and the stock name, which is all 3 of these right here. So what this is going to do is it's going to run through line by line, and if the account is the new highest, it's going to update this information, and then at the very end, we should have whoever has the highest account. I can now start to print this statement right here. So trader name is going to be equal to highest trader. You can either do a comma if you don't want to do the space, but I'm just going to do sum right here. And I'm going to say is equal to, and make sure you add that space because it won't have one. But owns, if I look at this statement right here, I want to print the trader name owns the account. So I'm going to continue on with this by doing a $sign. And I'm going to say owns plus string of highest account. The reason I have to do a string is because I'm doing a plus. So if I had this highest account right now is a float, And I cannot add a float to a string. So I need to convert it to a string first, and then I can add a string to a string. Plus, all right, so owns account in, and now I am going to say highest stock, because again, that is still a string, and I have to end it with stock. So after all of that, we should have printed this entire thing right here. And it does. So Betty owns 811.9999 in UAV stock. One thing we could do is, if you want to round this highest account, you can say round highest account. Let's go to 2 decimal places, and that will put it down. It actually rounded, so it's only at 1 decimal place now because there is no 2. There are not 2 decimal places. That is one way of doing this. There is another way. If I say print, I'm going to use a %s. So %s owns $, %s this one's not %s. This is %f. I'll explain this after I write this all out. In this is %s stock. Okay. These are placeholders. So %s is string, %f is float, and %s is a string again. So now I can, after I close the quotes on this string right here, I can do another %sign. And now I can fill in what each of those values should be. So the first one is going to be highest trader. I'm going to do a comma, highest account, and highest stock. It's going to automatically fill in each one of those in the order that we did it in. It's important to make sure that you have the right type of variable that you're using. So print that. I do have an error here. This is highest account. But you can see it does the same thing. If I wanted to round the account, I could go in here where I have the account and I can say round to 2. And it didn't. Oh, it's because I'm filling it in, so it's automatically going to do that. That's okay. That's just a way that you can fill that in, and you can do the same thing without having to type this massive equation in, and it goes a little bit faster. So hopefully you were able to find out how to do that before I showed you. If not, again, go ahead and make your own problems if you want to. Find some that are out there, but this was a quick intro to how to use simple equations, simple object types within Python. Stay tuned for the rest of the series. We're going to be looking at harder and harder things. We're going to have a whole bunch of more exercises, look at some different packages that you can use, and hopefully you'll be able to quickly learn how to code in Python. For now, thanks for joining. Again, please subscribe to the channel if you want more videos like this and you want to get updated when new videos come out for this series. After you get comfortable with Python, you can definitely go check out some more machine learning videos that I have that are using Python in order to actually put your skills to the test. So again, thanks for joining, and I'll see you in the next video.